Welcome back, friends. Today we are going to study about the gyroscopic effect in naval, aeroplane, and for the stabilizing of four-wheel and two-wheeler. So first, we are going to study about the gyroscopic effect in on a naval ship. The gyroscope is used for the stabilization and direction control of a ship sailing in the rough sea. A ship, while navigating in this rough sea, may experience the following three different kind of motions like steering, pitching, and rolling. Right? The top and front view of naval ship, the fore end and the ship is called the bow, and the rear end is known as the steer or up. Where the steering, pitching, and rolling are known as steering is the turning of this of ship in a curve while moving forward. Pitching the movement of the ship up and down from the horizontal position in a vertical plane about transverse axis, and rolling is the sideway motion of the ship about the longitudinal axis. So all three steering, pitching, and rolling is the movement of the ship are different, right? So different kind of movement of a ship is known as the steering, pitching, and rolling. Now suppose this is the figure of the naval ship, where for the stabilization of a ship against any kind of the above motion, means the steering, pitching, or rolling, the major requirement is that the gyroscope shall be made to process in such a way that the reaction couple exerted by the rotor oppose the disturbing couple which may act on the frame, right? So here the steering, which is the rear end, bow, which is the fore end, and transverse axis is the port of top port to port axis is known as the transverse axis, right? So this so the steering is a turning of the ship in a curve while moving forward. So when the ship is moving towards the forward direction or the bow direction, then the ship will turn. Then this turning process or turning movement of the ship is called as the steering. Whereas the pitching is the ship which is up and down at the horizontal position when the ship is steady as a longitudinal axis and ship is up and down from bow and stern, then the movement of the ship is known as pitching, where rolling is a sideway motion of the ship about the longitudinal axis, right? Means the when the ship which is moving forward direction, then the ship which is, or you can say the due to the vibration of or due to the way of sea, right? It will sideways motion of ship, which is known as rolling. Now, there's some ship terminology like bow, stern, starboard, and port, right? Where starboard is it is the right hand side of the ship looking in the direction of motion, and port is the left hand side of the ship looking in the direction of the motion, right? Consider a gyro rotor mounted on the ship along longitudinal axis as shown in figure, right? And rotates in clockwise direction when viewed from the rear end of the ship. The angular speed of the rotor is omega radian per second. The direction of angular momentum vector OA, right? Vector OA based on the direction of the rotation of rotor is decided using right hand thumb rule as discussed last lecture. The gyroscopic effect during the three type of motion of ship is discussed. The first case is left turn with clockwise direction, or you can say the left turn with clockwise rotor. Gyroscopic effect on steering of naval, right? So the effect of gyroscopic couple on the naval ship during the steering. So when ship takes a left turn and the rotor rotates in clockwise direction, view from stern, or you can say the view from the rear end, the gyroscopic couple acts on the ship is analyzed in the following way. So the figure which is shown in your screen is is the figure of rotor rotates in clockwise direction when viewed from the stern, right? So the longitudinal axis, also the three axes, which is axis of precision, axis of gyroscopic couple, and axis of spin, are shown as x, y, and z direction. Also, there are two couples which are generated: is active gyroscopic couple, which is due to the rotor rotation, and reactive gyroscopic couple, which is used to balance or stabilize the gyroscopic effect, right? Note that always reactive gyroscopic couple is considered for analysis. From the above, from this analysis, the couple acts over the ship between stern and bow. This reaction couple tends to raise the front end and lower the rear end, right? Means they raise the bow and lower the stern of the ship. When the when the ship takes the right turn with the movement of rotor is clockwise direction, when viewed from rear end, the gyroscopic couple acts on the ship is analyzed. Again, the couple acts in a vertical plane, means between stern and bow. Now the reaction couple tends to lower the bow and shape the raise the stern, right? Means it will change the position of stern and bow. Now, the third condition, if the ship taking left turn with rotating the rotor in anti-clockwise direction, view from stern, the gyroscopic couple act on the ship is analyzed as the couple acts over the ship is between stern and bow. Also, this reaction couple tends to press or dip the front end and raise the rear end of the ship, right? Means if ship is taking left turn with anti-clockwise direction, is the same gyroscopic effect will be generated as when the ship is making right turn with clockwise direction, right? Now the fourth condition, the ship will take right turn with the rotor rotates in anti-clockwise direction, view from this turn, the gyroscopic couple acts on the ship is according to the reaction couple tends to raise the bow of the ship and dip the stern. Means when the ship takes left turn with clockwise direction, or you can say the when the ship takes left turn with rotor rotates clockwise direction, is same condition when the ship takes right turn with rotor rotates in anti-clockwise direction, right? Now we are going to see the three conditions, the effect of the reactive gyroscopic couple to raise the bow and lower the stern, right? Effect of gyroscopic couple on a naval ship during pitching. When the pitching effect is made, the pitching motion of the ship generally occurs due to the waves, which can be approximate as a sine waves. During pitching, the ship moves up and down from the horizontal position in vertical plane, right? Where in the figure, the theta angle which is shown is a angular displacement of a ship axis from its mean equilibrium position, where capital A denotes the amplitude of swing is equal to angle in degree into 2 pi divided by 360, right? Where omega 0 is the angular velocity of simple harmonic motion, which is taken as 2 pi by time period, right? So angular motion of the rotor is given as theta is equal to A into sine omega 0 t. Consider a rotor mounted along the longitudinal axis and rotates in clockwise direction. When seen from the rear end of the ship, the direction of the momentum for this condition is shown by the vector OX, right? When the ship moves up the horizontal position in vertical plane by angle delta theta from the axis of spin, the rotor axis processes about z axis in xy plane. And for this case, z axis becomes the precision axis. The gyroscopic couple acts in anti-clockwise direction about y-axis and the reaction couple acts in opposite direction. So OX dash is the pitching upward and delta theta, and OX dash pitching downward delta theta is shown in your figure. I is figure B and figure C. Right? In clockwise direction, which tends to move towards right side. However, when the ship pitches down the axis of spin, the direction of reaction couple is reversed and the ship turns toward left side. Right? So for the both cases, ship make two different kind of turn in right side and left side. Similarly, for the anti-clockwise direction of the rotor view from the rear end of the ship, the analysis may be done, right? And the analysis can be changed the direction of the ship. Now, the third effect, rolling. The gyroscopic effect on the rolling of ship, right? The axis of rotor of a ship is mounted along the longitudinal axis of the ship, and therefore there is no precision of this axis. Thus, no effect of gyroscopic couple on the ship frame is formed when the ship will roll, right? So no kind of analysis which is taken or which is done while the gyroscopic effect on the rolling of ship, right? So there are three kind of gyroscopic effect: rolling, steering, and pitching during the ship. Stability of four-wheel vehicle negotiating a turn, or you can say the stability of a four-wheel drive moving in a curved path. Consider a four-wheel A, B, C, D of an automobile locomotive taking a turn towards left. The wheels A and C are the inner wheels, whereas B and D are outer wheels. Right? When the four-wheel drive take turns left, then A and C wheels, which are the inner wheels, whereas the B and D are the outer wheels. Right? Consider a four-wheel automobile vehicles as shown in figure. The engine is mounted on the rear with the crankshaft parallel to the axis. The center of gravity of the vehicle lies vertical above the ground, where the total weight of the vehicle is assumed to be act upon, right? Where some terminologies which is taken as h is the distance of the center of gravity vertical above the road surface in meters, x is the width of track in meters, iw is the mass moment of inertia borne of the wheels, omega w is the angular velocity of the wheels or velocity of a spin, IE is the mass moment of inertia, the rotating parts of the engine. Omega is the angular velocity of the rotating part of the engine. Capital G is the gear ratio. Omega E divided by omega W, and small v is equal to linear velocity of the vehicle in meter per second. Right? So we have to study about the stabilization of four wheel while taking a turn in curve road, right? So the reaction due to the weight of vehicle, first reaction which is generated due to the weight of the vehicle is assuming that the weight of the vehicle is equally distributed over the four wheels. Therefore, the force on each wheel during each wheel acting downward is mg by 4. Okay, and the reaction by the road surface on the wheel acts in upward direction. So Rw is equal to mg by 4 is W by 4, which is taken in the figure, W by 4, W by 4, W by 4, and W by 4, right? The second effect, which is effect of gyroscopic couple due to the wheel, effect of gyroscopic couple due to the wheel is Cw is equal to 4 times Iw into omega p, because there are 4 wheels are used. Third effect is the effect of the gyroscopic couple due to the engine. Gyroscopic couple due to rotating parts of the engine is Ce is equal to Ie into omega P, right? So which is taken as IE into capital G omega W into omega P, where capital G is equal to omega E divided by omega W, right? So therefore, the net gyroscopic couple or total gyroscopic couple which is reacted is Cg is equal to Cw plus or minus Ce is equal to omega into omega P in bracket 4 I omega plus or minus IE capital G. When the wheels and rotating parts of the engine rotates in the same direction, then positive sign is used in above equation, right? Otherwise negative sign is should be considered, right? So when the wheels and rotating parts of the engine rotates in same direction, then the momentum will be some momentum of total momentum is the summation of wheel and engine momentum. If the rotating parts of the engine revolves in the opposite direction, then the total momentum is the subtraction of the wheel momentum from the engine momentum. Assuming that the vehicle is taking a left turn, the reaction gyroscopic couple on the vehicle acts between outer and inner wheels, right? So the gyroscopic effect or gyroscopic couple which is generated between the inner wheel and outer wheel, which is shown as a capital G, right? So the gyroscopic couple tends to press the outer wheels and lift the inner wheels, right? So the gyroscopic couple which is reacted or which is tends to press the outer wheel and lift the inner wheel. Due to the reactive gyroscopic couple, vertical reaction on the road surface will be produced. The reaction will be vertically upward on the outer wheels and vertically downwards on the inner wheels, which is taken as P by 2 downward direction for the inner wheels, Q by 2, P by 2, P by 2, Q by 2, right, for the A and C wheels, which will be downward direction, and P by 2, Q by 2, and P by 2, Q by 2, which are the upward direction for the outer wheel. These are the reactive force or reactive gyroscopic couple, right? So the road reaction on each outer wheel, which is taken as P by 2, is equal to Cg by 2x, right? Now suppose when the vehicle moves a left turn or right turn, right, in the curvature area or curvature road, then the centrifugal effect or centrifugal couple also be generated, right? When a vehicle moves on a curved path, a centrifugal force act on the vehicle in outward direction through the center of the gravity. The force forms a centrifugal force from this centrifugal couple is equal to Cc is equal to mv square h by r, and centrifugal force which will be produced is Fc is equal to m omega p square by m omega square into r. So equation will be mv square upon r. Due to the centrifugal couple, the vertical reaction on the road surface will be produced. The reaction will be vertically upward on the outer wheels and vertically downwards on the inner wheels. Let the magnitude of the reaction at the outer and inner wheels will be F newtons. Then the road reaction on each outer inner wheels will be Q by 2 is taken as the centrifugal force as F by 2, which is Cc upon 2x. So the total figure is W by 4 is the weight reaction due to the weight. P by 2 is the reaction due to the gyroscopic couple, and Q2 is the reaction due to the centrifugal couple, right? So all three reactions on the all wheels are shown in this figure. So the total vertical reaction at each outer wheel is PO equal to W by 4 plus P by 2 plus Q by 2, and the vertical reaction at each inner wheel is W by 4 minus P by 2 minus Q by 2, right? So the reaction, total vertical reaction at on the each wheels are shown in the figure. Also the effect of the gyroscopic couple on each wheel will be discussed, and all the each wheels, the centrifugal couples also be discussed. So the stabilization or the gyroscopic effect on the four wheel drive is being discussed, right? So now we are going to discuss about the gyroscopic effect on the aeroplane. Now when we are discussing about the gyroscopic effect on the aeroplane, so the aeroplane are subjected to gyroscopic effect when it taking off, landing and negotiating left or right turn in the air, right? So suppose first the when the engine and propeller rotates in the clockwise direction, when we this is discussed in our previous lecture, right? So the case one, the propeller rotates in the clockwise direction when seen from the rear end, and aeroplane takes turns toward the left. So these all conditions are shown in this figure, right? According to the analysis, reactive gyroscopic coupled stands to dip the tail and raise the nose. When the gyroscopic effect or when the gyroscopic couple is generated due to the propeller or engine rotates in the clockwise direction, right? When the propeller or engine which is rotate in the anti-clockwise direction, then the analysis which is say which is uh, done, or according to the analysis, the reactive gyroscopic couple tends to dip the nose and raise the tail. But when the propeller or engine rotates in anti-clockwise direction, right, same thing is shown all the things in this figure, right? Now, case 3. When the propeller is rotates in anti-clockwise direction when seen from the rear, an aeroplane turns the left turn, right? So the gyroscopic couple which is produced, right, which is done or which is analyzed with the help of right and thumb rule, right? So the spin vector, precision vector, and gyroscopic couple vector are taken. With the help of right and thumb rule, with the help of right and thumb rule, we have to see the anti-clockwise direction. Propeller rotates in anti-clockwise direction. So we have to take the right and thumb in this spin vector as the our four fingers wound on a vector as the anti-clockwise direction, right? Wound, our four fingers are wound on the x-axis as a anti-clockwise direction. So the finger shows the gyroscopic couple vector, and our hand or the direction of the hand which is denotes or which is present the precision vector. Now the in the direction of our finger which is shown the active gyroscopic couple vector, and the opposite direction, in the opposite direction, or you can say in the opposite axis z, which is shown the reactive gyroscopic couple, right? So when the propeller rotates in anti-clockwise direction, then due to the active gyroscopic couple, this part, active gyroscopic couple part will be raised, where the reactive gyroscopic couple parts will be lower. So this behind part means the rear part of the aeroplane will be in raised. So the tail of the aeroplane will be raised and nose of the aeroplane will be tilt, right? So how the hand right hand thumb rule will be used? You have to use your right hand thumb towards the direction of the propeller rotates, right? You have to use it practically, otherwise you can't be explain, or you can't be understand how the right hand terms will be used, right? So the conditions of the aeroplane, or you can say the gyroscopic effect on the aeroplane, gyroscopic effect on the naval ship, and gyroscopic effect on the four wheel drive for the stabilization has been discussed.